Okay, let's look at page 6 in your chapter 7 notes. So far, you've learned to solve systems of equations by graphing them. And you found that when you graph a system of equations, you either have intersecting lines, which gives you one solution, parallel lines, which gives you no solution, or overlapping lines or coinciding lines, which give you infinitely many solutions. Okay, then we learned you can solve through substitution and you could solve through elimination. But if we look at the example on page 6, number 1, looking at this, when we first look at it, let me just fix this. You're like, okay, well, I can't do elimination because I do not have a scenario where there's the same variable with the same coefficient and opposite sign. So what I would say to you is, in this case, let's just cross out this and say, okay, there's nothing here. If you could have that be anything that you wanted it to be, what would you want it to be? And I'm assuming you say, well, it would be great if it was 2y, because if it was a positive 2y, then I could eliminate the y's because I have the same coefficient but opposite signs. So what kind of magic wand can we use to change this into a 2y? Well, we can multiply every single term in this equation by 2. So let's do that. And this becomes 4x plus 2y equals 5. Now I'm going to rewrite the equation on the bottom. And now I say, well, look at this. Now I have the perfect scenario. I have the same coefficient, opposite signs. And when I add these together, the y's disappear. So I end up with 7x equals, anybody notice a mistake I made? What's 2 times 5? So don't do what I just did. Don't think, oh, I'm multiplying everything by 2 and then forget to multiply the constant by 2. So this ends up being 7x equals 14. Divide by 7, x equals 2. Once I know x is 2, I go back to my original equation, either one, you can pick either one, and you plug in x for 2. So 4 plus y equals 5, y equals 1. So my ordered pair is 2, 1, which again, I plug it back in, check into both equations mentally and make sure it works, and it does work. Okay, so this method is we are solving through elimination, but before we eliminate, we have to either multiply or divide one or both equations, okay? So let's look at number 2. So for number 2, I have 4x minus 3y equals 12. I have x plus 2y equals 14. Notice my variables are lined up, which is how it should be. And I'm looking at my coefficients. And I notice that I have a 4 and I have a 1. And I think to myself, well, I really wish that 1 was a negative 4. And that's an easy fix. I can multiply the entire bottom equation by negative 4. So now I have 4x minus 3y equals 12. And the bottom equation becomes negative 4x minus 8y equals negative 56. So when I add my x's together, my x's are eliminated, and I end up with y equals 4. Now, once I know y is 4, I can pick either equation. I'm going to pick this equation to plug back in. So x equals 6. So my ordered pair is 6, 4, which I plug back into both of the original equations, make sure it works for both, and it does. Okay, so now what we do is we line up our variables and we look at the coefficients and we say, is there any way we can multiply one equation to eliminate the variable? And whenever you have a scenario where you can multiply just one equation, that's what you choose. So let's look at number 3. 9x minus 5y equals negative 2. 3x minus 2y equals negative 2. So I look at this. I see a -2 and a -5. It's not that easy to multiply a -2 to turn it into a +5. But I notice 3 and 9. 9's a multiple of 3. It's very easy for me to turn this 3 into a -9, which is what I want. So I multiply my bottom equation by -3. I get 9x minus 5y equals -2, and then -9x plus 6y equals 6. Now I eliminate my x's and I get y equals 4. I plug in to either equation. I'll pick the top to solve for y. Let me solve for x. I get 9x equals 18. Excuse me, x equals 2. So my ordered pair is 2, 4, which again, I am going to plug in, make sure it works. So now, number 4 will also work out pretty easy. So I want everyone to stop the video and try number 4 on your own and turn it back on when you're done. So for number 4, we have 7x plus 3y equals -1. 4x plus y equals 3. Here, I have a scenario where 3 is a multiple of 1, so I know I can easily multiply just this equation to get them to have the same coefficient, opposite sign. I'm going to multiply by -3. So I get 7x plus 3y equals -1, and -12x minus 3y equals -9. The y's are eliminated. I get -5x equals -10, x equals 2. And when I plug x in, I get y equals -5. So my ordered pair is 2, -5. And when I plug it back in, I see that it works. Okay. Now, let's look at this word problem. It says 3 times one number equals twice the second. So I let x equal first, y equal second. So 3 times the first equals twice the second. Twice the first is 3 more than the second. Okay, so now I have my 2 equations. I'm going to rearrange them, just put it in somewhat standard form. And I look to see if one is a multiple of the other, and I see y, -1 and -2 is a multiple of -1. So if I multiply this by -2, I create a scenario where I have same coefficient, opposite sign. I eliminate the y's, -x equals -6. So I end up with 6, 9 as my 2 numbers. Now, I didn't have to let x be the first. I could have let y be the first. So really, you end up with 2 numbers, 6, 9. They're not necessarily x, y, but they could be. Okay, so now let's turn the page. Turn to page 7, because on page 7, we'll see what happens when things don't line up as easily as the ones we've done so far. Okay, so on page 7, if we look at this, 2x plus 3y equals 5, and 5x plus 4y equals 16. Now, the problem here is 5's not a multiple of 2, 4's not a multiple of 3. So I'm not going to be able to just multiply one equation without using fractions and get the coefficients to be the same coefficient, opposite sign. But when you have a scenario like this, what I like to think about is, okay, I have a 2x and a 5x. Think of it, if you had 1/2 plus 1/5, what would your common denominator be? Your common denominator is your lowest common multiple. So I'm really looking for the smallest common multiple between 2 and 5, or the smallest common multiple between 3 and 4y. So I'm going to decide to eliminate the x's first. So between 2 and 5, my common multiple is 10. So I say to myself, how would I turn the 2 into a 10? Well, I'd multiply this equation by 5. So if I multiply the top equation by 5, and then I say, well, now I want this to be a negative 10. So what would I multiply 5 by to get it to be negative 10? And it would be a negative 2. So I get negative 10x minus 8y equals negative 32. I eliminate the x's, and I get 7y equals negative 7, y equals negative 1. Okay? And when I substitute back for x, I get x equals 4. So I know my answer is 4 comma negative 1. But what I want you all to do now is you're going to take the same problem, and I want you to try to do it over. But this time, I want you to try to eliminate the y's. So I want you to think about what would be a common multiple of 3 and 4, and how would you multiply each equation to end up having the y's have the same coefficient, opposite sign. So stop the video, try to do it, and turn it on when you're done. So my common multiple between 3 and 4 is 12, which means I'm going to multiply my top equation by 4 to get 12y, and my bottom equation by negative 3 to get negative 12y. So when I do that, I get 8x plus 12y equals 20, and I get negative 15x minus 12y equals negative 48. When I add them together, I get negative 7x equals negative 28, and I get x equals 4, which is exactly what I got before. So the answer is still 4, negative 1, as it should be. But instead of eliminating the x's this time, we eliminated the y's. Okay? So what I want everyone to do now, there's 2 problems for you to practice. I want you to stop the video and see if you can do number 1 and 2. Okay, so number 1, 7x plus 3y equals negative 12. 2x plus 5y equals 38. I'm going to try to eliminate my y's. I could have eliminated my x's, but I'm choosing to do my y's. So that means I'm going to multiply the top equation. 3 times 5 is 15. So what do I have to do to 3 to make it 15? I'll multiply this by a negative 5, and I'll multiply this by a positive 3. So I end up with negative 35x minus 15y equals 60, and 6x plus 15y equals 114. I eliminate my y's, and I get negative 29x equals 174, x equals negative 6, and when I plug in negative 6, I get y equals 10. So my answer is negative 6 comma 10. And then for number 2, I have 4x minus 3y equals 8, 5x minus 2y equals negative 11. This time I'll eliminate the x's by multiplying the top by negative 5 and the bottom by positive 4. I get negative 20x plus 15y equals negative 40. 20x minus 8y equals negative 44. 7y equals negative 84. Y equals negative 12. And if I plug in for x, this is my solution. Okay? And then you can read a little synopsis on how to use multiplication to eliminate variables at the bottom of page 7.